Okay, so here's what I've discovered so far. The video works, and it's pretty big in terms of file size. So here's an alternative that we're going to try and see what happens. So for those of you who love YouTube, like me, go to youtube.com/AC for Ashbury College, and my last name, which nobody knows how to spell the first time, so I suggest you pay attention on how to spell it so that you don't get an error. Enter. I just got an email. Huzzah! I have now created us an AC Math channel where I'm going to start trying to put all of these different videos that we have, and well, we'll see what happens. Anyway, back to decomposition. So the whole purpose of decomposition is to take any quadratic. Well, we'll start with quadratics, but we're looking at things that are of this form, and we want to go from a form where everything is added together. So we have something plus something plus something. We want to go from that to some other form where rather than things that are added together, we want things that are multiplied together. And well, I'm not going to fill that in because I don't want to use other letters. But that's the whole idea of factoring. We're going from something that's added to something that's multiplied. Now, decomposition is a method where, for our intents and purposes, I guess, for this easy, straightforward example that we've looked at before, for all intents and purposes, decomposition looks at two things. It looks at a product, and it looks at a sum. Now, the product is literally the coefficient in front of the x squared part, or in other words, the a constant. In this case, we've got a hidden 1 out here. And you multiply the a value times the c value. So really, it's a times c. In this case, 1 times 6, or 6. Easy. The sum part is the coefficient of the linear term, or the x term. In other words, the b value. In this case, straight up 5. You got to pay attention to the signs as well, right? So this is positive 1 times positive 6, and our sum, or our b value, is positive 5. So signs are important here. Now, how does this play out in terms of decomposition? Well, every single time you decompose, you are looking for two numbers that multiply to 6 and add to 5. Okay? So we're looking for two numbers that multiply to 6 and add to 5. In this case, we're looking at positive 3 and positive 2, right? 3 times 2 is 6, 3 plus 2 is 5. Bingo. So what I can do is I can now rewrite this line as x squared, I'm going to leave it alone, and I'm not going to write the 1 out in front here, plus. Now, I'm working with 3 and 2. Now, the reason we call it decomposition is because we're taking the middle term and we're going to decompose it, or split it up, into 3x plus 2x. And then we have our 6, and it continues. So the idea of decomposition is we're going to take the middle term and split it up into two separate terms. Notice we haven't changed anything, right? I still have x squared plus 5x plus 6, which was my original question. So I haven't really changed anything. I've just done a little mathemagic. Now, why does this matter? Why is this helpful? Well, we did learn about grouping. So what I'm going to do is I'm going to take this stuff and I'm going to group it. So I'm going to take the first two terms and I'm going to group them in their own separate bracket, and I'm going to group the second two terms into their own separate bracket. Now, notice how I have to have this plus sign still in the middle here. If you wanted to, you could, use your regular algebra techniques to simplify this, and you would get the same thing back. But I like to, when I group, I like to use brackets, so I'm going to. So this is step 2, I guess. Step 1, step 2. Well, step 3. This is step 1. Decomposing is step 2. Grouping is step 3. Step 4 is common factor. each of the brackets by themselves. Okay, so if my common factor here and here is going to be an x, so I'm left with an x plus 3. My common factor here is just a 2, and I'm left with x plus 3. Now, this is why I say decomposition it always works and it's foolproof. If you've done this stuff properly, and you've done the common factor part properly, if you've done it correctly, this and this must be the same. If they're not, then something is either wrong or it's not factorable. Okay? But the reason decomposition is nice is because it gives you a check halfway through the problem. It tells you whether or not you've done something right or wrong. Okay, so the nice thing about deciding that this term and this term are the same is that those themselves can actually come out as a common factor, right? So I've pulled out another email. I've pulled out an x plus 3 as a common factor, and what am I left with? I'm left with an x and a plus 2. I've unfished, I guess, if some of you like that language. I've unfished an x plus 3, and what I'm left with at the end of it is an x plus 2. Hey, bingo! Something times something. It looks a lot like this. Something times something. This is considered factored. And I'm done. So this is the machinery of decomposition. And if you have to factor something that's in quadratic form, and we can look at various examples of when it will work and when it won't work. Maybe that'll be in my next video, is various examples. Decomposition, the machinery, it will always work. It is foolproof. If it doesn't work at every step of the way, then something is wrong or it doesn't factor and it's an unfactorable question. Okay? But this is the nuts and bolts of decomposition. So if you need to remember the machinery of how it works, this is the procedure that we use every single time. Goodbye.